So I believe that our students at Stanford have ideas in their head that can change the future of transportation. But it's highly likely those ideas stay in their head unless they have the opportunity to get them out on the road. And that really is the purpose of this lab, to try to reduce the amount of time between a student having an idea in their head and test driving it out on the road or the racetrack.
The ultimate vision of the types of research questions we ask here and the types of developments we make is to design controllers that improve the safety of the next generation of automated vehicles. We'd like to design controllers that can stabilize cars right before they lose control and avoid accidents right before they happen on a broad scale that impacts all of us who are on the roadways.
Everyone in our lab is trying to make driving safer, and specifically I am doing that by looking at drifting and being able to do that autonomously. So in the most extreme driving scenarios, your car will be able to maintain control of its velocity, position, even while it's going sideways.
There are a lot of cases where people are tired, distracted, otherwise unable to safely operate a vehicle, and by helping them out and making their car safer, we can prevent fatalities on the road and also make driving a much more enjoyable experience.
My favorite part of our work is the simulations, the stuff that happens behind the scenes, but the most exciting part is when we take the cars out to the track and get to see them perform in real life. And that's not easy though, it takes a lot of work. So we have to trailer the cars, we have to drive a few hours.
We have to make sure that the battery pack on the car is charged. We check all of the bolts and different mechanical assemblies to make sure the car is safe for us to drive. And we need all of our computers, GPS, and sensors to be up and running. In order to test these driver assistance systems, it's really helpful to place the driver in a virtual environment. So we have them put on a virtual reality headset and view a world that looks just like the real test track, except in this case we can safely put other road users, for example vehicles and pedestrians, into the scene so we can get naturalistic driving behavior while also testing on a real vehicle.
I've always enjoyed doing dynamics and controls. That was always my favorite area of engineering. And when I came to Stanford, I was interested in finding a way to apply that was meaningful to me. And this idea of making cars safer, I get in a car almost every day, and I want the cars that I get in and all the cars that drive around me on the roadways to be safe. Especially as a new mom, safety is something that's so important to me. And so this lab, their mission of making vehicles safer for everyone, is something that really means a lot to me.
I'm very motivated by the fact that we could be putting new technology on the road in the near future, especially with driver assistance systems that are increasingly prevalent on cars today.
So we spend a lot of time out on the racetrack trying to make sure that we can have cars move in exactly the way that we want them to move. And one of the questions that comes up naturally is, well, how do we want them to move? And how do we want them to move in situations that could be dangerous, that could be emergencies, that could result in crashes regardless of what we do? And pretty soon the engineers start to realize that this goes beyond engineering and really hits issues of the law. It hits issues of ethics. And we need more than just the mathematics and science of our engineering training to be able to answer these questions. Hopefully we bring all of these aspects together when we're training students and when we're pursuing these research directions.
Hello, good evening, thank you. Thanks for coming, everybody, and thanks for watching online. This is a really special occasion. My name is Tom Byers, and I'm a professor in the School of Engineering. So is Chris, and we have a good friend here from Michigan we'll introduce you to. The School of Engineering has got it. They're really dedicated to emphasizing ethics and the practice of engineering. In my case, I run the center called STVP. It's the Entrepreneurship Center at the School of Engineering, and we've redoubled our efforts paying attention to values and principles and ethics. And if I don't stop right there, I won't stop, because it's been very exciting. We're here, though, to focus on those cars sitting out in the driveway. It's going to be a really special couple of hours. We'll kick off the first half of that by doing some chat up here. and we're going to take questions. So is there note cards in there, Catherine? Is that the way it works? Yeah, you got your note cards, and on occasion pass them to the middle, and Catherine will collect them and bring them up here after I fire some questions that we put together. In fact, it's been a really team effort, not only in putting together the event, and of course, share our gratitude to having us over here, Chris, because it's his lab, and all the staff at the School of Engineering, but also the staff here at the Entrepreneurship Center. They helped put together the sort of questions I'm going to share with Chris and Tony, and there's a lot of them. So we're going to keep this moving. Only thing I'm afraid of, these folks, once I throw a match on them, they're going to take off. When all the prep calls, it's just been fascinating. I don't know what drove you to come here, but probably a car. And the motivation is, what is it going to be like, when they're self-driving? No matter what your interest is to get you here, it's something that we all care about, and certainly in the news all the time. In a situation where there's a lot of stuff in the news today and these kinds of days, but this keeps getting a lot of attention for good reason. So, before I introduce them, I was just thinking, I see the cars out there, and I see you in here, so why don't we just do the interview in one of the cars driving around, like car karaoke? And you don't mind, right? You sit here and watch on video, but we'll have the video guys just follow us. What do you think about that? Can we do that, Chris?
Not quite set up to do that right now.
Okay, someday we're going to come back and do this again.
We can talk about the ethical dimension of that.
Yeah, and we're going to come back someday. How about this? A few years down the road, and we'll do the entire interview by driving around in the car together. There's 3 of them out there, and that's going to be the highlight when we're finished up here. So, Chris is the professor. Emeritus now, but still very, very involved, that is in charge of this lab. And I've known him for a long, long time and admired him. So when I got this offer to do this gig, it took about 2 seconds to think, wow, I get to come back over here and help share what's going on here, specifically around this topic of ethics. So Chris is a graduate of Berkeley, which I am as well. So we got to say "Go Bears" here, just for the audience to hiss us. You can hiss if you want, but we're proud grads of that. And we have Tony from Ford Motor Company. He's part of their advanced technology group. And he'll tell you all about that as well. And he's a graduate at the University of Michigan. So he came out just to be with us live, which is very, very cool to be live. I mean, this is outstanding to be live in this place. So should we get underway?
Let's do it.
All right. So let me start with you, Chris. And I'm going to use some questions here because these were vetted with our team and also some students, so we make sure we satisfy everybody before we start hearing some questions on the fly. So give them to us as well. So Chris, I want to talk about this. Let's start with you and talk about what got you interested in ethical considerations regarding AVs.
So it was almost exactly 10 years ago that I got an email from a couple of faculty members, actually 3 of them, George Bakey, Patrick Lynn, and Keith Abney. And they reached out to me and they said, we're familiar with your work on autonomous vehicles. Are you interested in working on the ethics of these vehicles? And I was like, the what? So I had grown up reading Isaac Asimov's robot novels. Mm-hmm. And so that was the first, the only touch point I had with autonomous vehicle ethics was, I'm like, you mean like the laws of robotics? And they're like, yeah, kind of. I mean, people have looked at that. But they said, we're actually part of the larger robot ethics community. I was like, that's a thing? There's a robot ethics community out there? Indeed there is. And it's a fantastic group. And I would say that, Patrick and Keith in particular kind of took me under their wing and taught me an awful lot about applied ethics and about some of the interesting issues there. And I started to realize that, wow, this actually is fascinating. This is a really important topic. It's not just science fiction, although it kind of sounds like it sometimes. And what we ended up with actually surprisingly kind of came back to the laws of robotics. But this is something that's really very real. So we looked at it from a research standpoint. I worked with several of my PhD students, including Sarah Thornton, on value-sensitive design and some of these aspects, taught a course on ethics and equity in transportation systems. And so it really became, from this like random email essentially a very big part of my career and academic program here.
What about you, Tony? How does your interest peak around this?
I didn't have a preference to have interest in ethics at the end of the day. My work in the space started in much like Chris's in terms of robotics in our manufacturing operations. We had set up a group to do advanced applications with AMRs, with autonomous mobile robots, as well as cobots in the manufacturing space to reduce costs and increase efficiency. Safety is a big part of that. At the end of the day, we put constraints in place that limit the need for much ethical consideration in terms of limiting speeds, limiting the physics in terms of how much damage we might cause to a person if someone is struck by a robot, for example. Moving into the autonomous vehicle space, that changed, right? I think we understood as an automotive company how to build safe platforms, how to protect for electrical malfunctions that could lead to failures. But there was a missing piece to this. So we were talking about the platform. We weren't talking nearly as much about the safety of the driver itself, the robot in this case, and how it was performing the driving task. And as we progressed this conversation, the eyebrow just kept raising. There was a huge gap here that needed to be solved, right? When was it appropriate to break traffic code, for example? That was the one framing question that kept coming up, not just in internal conversations, but within industry consortia as well. And it begged the question, we needed to form a group. We needed to understand, when was this appropriate? And so at the time, I wouldn't say that we framed this as an ethical consideration. It was more of a practical problem we needed to solve, and it evolved from there.
Yeah, and then so how did you guys meet?
In a dark alley. No, Chris started as a safety advisor with Ford in 2019, just before the pandemic had started, and we were looking for synergies in terms of where Chris would participate within our AV activity. We had started using value-sensitive design as one of the approaches of how we would analyze various situations where it might be appropriate to break traffic code, for example. So that organically was an area that he was working with us.
Great. And so there, in the announcements for this event, there was some homework. Did you see that at the bottom? I'm going to look at my students first and say, did you see that at the bottom? And did you read it? It was a little bit of light reading. It was from the Journal of Law and Mobility. I'm joking when I say it was light reading. But I got through it twice. And it's worth talking about because it's going to be the crux, I think, of and I want to get at it right away. The crux of the evening is we're all concerned about safety. I've got this, what struck me right away in the piece, and then I want to talk to you about how it came about. And then we'll get into, the big takeaways. But it's called Exceptional Driving Principles for Autonomous Vehicles. But the very first part, you lay out what your actual goal is. And you know what? I think this actually applies to, I told you that all the areas of the School of Engineering are rethinking their approach to teaching ethics and values and principles, including us. And I think we all could, and since we're an engineering school, we all follow this. This is developers must handle such cases in a manner, they're talking about autonomous vehicles, but it applies to all of us, in a manner that is legally defensible, ethically sound with regards to its treatment of human harm, and planet harm, if you want to throw that, and technically implementable. So, that sweet spot of the trifecta there. So, first of all, how did this piece come about? Because it's like 6 authors, and why was it so important to get out? It was published this summer, so this is very timely.
I'll start, Chris, if you don't mind. So, the motivation for publishing the work ultimately was because, safety is not something we view as a competitive aspect of the AV domain. This is an area that represented some uncertainty. We had a strategy that we put together that we think is appropriate for dealing with some of these challenging situations, and we thought this was important for the public to be aware of, to be transparent in terms of how the vehicle would operate, for government organizations, for example, and other developers to also have an opportunity to critique on the strategy that we were using. So to that end, the best way to achieve those goals is to put something into the public domain. So.
Yeah, this grew out of some of the conversations as well that we had kind of stemming from that initial email in the robot ethics community. So Emily Frascaroli, who's a lawyer at Ford, who's one of the co-authors, actually had attended some of these sessions. And I was very struck by her practicality on some of these issues of legality. Some of the people in the room would say, wait a minute, with automated vehicles, the manufacturers might get sued. And her point was like, that happens to us all the time, right? This is reality. This is not something to dodge, but it's something to embrace. And so, that was part of the reason I think that they reached out to me to come to Ford in the first place.
Yeah.
And then that created a really great group of people in an environment to solve these sorts of issues that Tony thought.
Well, let's assume that not everybody had a chance to read it, and maybe this will be a stimulus to go have a shot at it afterwards. So let's break it down a little bit. It's about, well, in the title, exceptional driving scenarios. What are those to begin with?
So I think Tony actually coined the exceptional driving.
This is a lesson
term.
on being careful about what you call things off the cuff because it can stick.
Because it can stick. So it's gone through a number of different meanings, but where we've kind of landed on in the paper is an exceptional driving situation is one where the vehicle cannot meet the duty that it owes to different road users or to the traffic code. And the whole idea of this paper really is that driving is a social contract. So if we start to talk about ethics, there's many ways of formulating ethics. We said, actually, there's no reason to go back to the drawing board here and start from scratch. It's like we have an ethical framework for thinking about driving as a social contract, because driving is a social contract. It's a perfect example. We trade our individual liberties. I can't go as fast as I'd like to go on the road. I have to obey
Except
the
during
speed limits.
COVID. Remember the lockdown people?
Well, we had a slightly different social contract.
Yeah,
then.
exactly.
But in general, I can't do everything I want to do out on the road. I have to follow the road rules. But what do I receive in return for giving up those individual rights? I get civil rights. And so we said, look, society has actually kind of figured out the basic ethics behind driving in terms of this social contract. The contract is based around the duty of care that we owe to other road users. And so if we can simply formalize this and adhere to this, then we actually have a really nice way of thinking about automated vehicle ethics. Again, not reinventing the wheel, not trying to get a bunch of people in the room to say, how do we be ethical? But in fact, doing what society has evolved over the last 100 years to accept in the form of our legal duties.
You want to build on that, Tony?
I do. So, this started from a pretty simple initial question. It started with speeding, for example. Lots of humans speed under various circumstances. AV should naturally speed as well to behave naturalistically, to behave like humans behave. And this was something that was troubling for the group at the end of the day. Why would we think that AVs should, in terms of software developers, pick and choose which rules we follow and which we don't? I think there's a general thought out there that the traffic code and the existing frameworks that we're leveraging as part of this work were built with humans in mind, and therefore were not applicable to robots. And so I think we're talking about the conclusion essentially in the paper, but part of this was building up and proving that in fact the existing framework could be applied to robots. And I think that was maybe what wasn't as obvious at the beginning of this activity.
How many of you heard of the trolley car problem? It's pretty famous in philosophy. First of all, how about let's throw it to you.
I will say, as you're flipping the pages here, we were joking before we started that as we were starting this development at Ford, we would always start the discussions with, we are not going to address the trolley problem today. We don't want to talk about it. We don't want to argue about it. This is just about traffic code, and slowly it evolved into addressing the trolley problem.
Well, the elephant in the room then, the trolley car in the room. What is it? What's going on here?
All right.
Dive in.
This is sort of it's been a pet peeve of a long time for me, but I have come to embrace it.
Okay.
So the trolley problem is what most people think of, I think. When I say I work on AV ethics, people will normally stop and be like, oh, do I run over the old woman or the baby? It's like, that is not what we're talking about. So why do people think that's what we're talking about? Well, first of all, it's because of some work at MIT, which actually decided to crowdsource ethics by saying, who would you prefer to run over? It's a great way of, essentially revealing societal bias, but it has nothing to do with programming automated vehicles. So the trolley problem in its fullest form, which is, by which I mean, the form that you probably see the internet memes on, is really a combination of problems that was proposed by Judith Jarvis Thompson. She said, okay, I want to propose two problems here. One, you have a runaway trolley car train, and you have a bystander who has no connection to this standing at a switch. The trolley car is going to run over 5 people, but the bystander can pull the switch and send it onto another track, at which point only one person will be killed. Now I've got a second scenario. Similar scenario, runaway trolley car, except now I can push a fat man off the bridge in front of the trolley car. Now, are these morally equivalent? Her comment was no. And the belief in this paper was that these are two very different situations, that I have no moral obligation to let this tragedy fall out of the blue on 5 people, when I could have that tragedy fall out of the blue on 1 person. So her feeling was the bystander is fully morally justified at pulling the switch. But she said, ultimately, rights should trump utility. In other words, I can't do this if I'm going to violate somebody's rights. And in fact, that's actually what we ended up on in the paper, and that's where we went from saying we're not addressing the trolley problem to realizing that we've solved it. We said, what the automated vehicle should do would be to observe its duty that it owes each and every road user there. It should never violate the duty it owes to any person. Now, if a person violates the duty that it owes to the vehicle should try to resolve that, which shouldn't involve somebody else who was previously uninvolved in the accident. And if you make that very simple rule, which is that the car obeys strictly the duty of care to each individual out there on the road, the trolley car problem goes away. Why? Because we went back to the very beginnings of this and said, it really is a question of rights. And that's the thing, we will not violate somebody else's rights because someone has deemed that societally somebody's life is more valuable than somebody else's.
I know you're not going to talk about it, but I'm going to get you to.
No, I'm thinking back to the discussions that we had on this topic leading up to this, and so Chris is presenting this as a very structured, ethical conversation, and that's not quite how this happened over the phone, right? The notion of taking an action that would involve another road user that was obeying the rules, for example, and involving them in a situation that they weren't originally part of was, I think the words we said was un-American at the end of the day. We just didn't know at the time that there was actually a framework that protected for this.
Yeah.
So we say that this framework essentially solves the trolley problem. I think we would argue that it doesn't exist under this framework, right? That if you're following these requirements strictly, you don't have that consideration.
Well, before getting prepared for this, my introduction to the trolley problem, because maybe I studied it back in college, but was The Good Place, the television show. So I said, I remember that. So it got me interested to look it up. And then I went over and I actually tried the moral machine. This is the MIT approach that you were just talking about, Chris, right? The moral machine. Yep. And the website's still up. It's from a project that was, I guess, alive between 2016 and 2020, something like that. But they still maintain the website. You can go home tonight and take the test. And it's a crowdsourcing kind of thing about who should live and who shouldn't based on their sort of some characteristics. It's kind of disturbing when I was filling it out.
Well, it is. I'm glad that you're actually disturbed by it. I mean, it is more amusing to answer those questions than it is to read our paper. I will admit to that. But it is sort of at the end of the day when you start to think about crowdsourcing ethics, I think it should make everybody a little bit queasy to be like, well, wait a minute. There's all sorts of ways for societal bias to get in there. And even when people say from a utilitarian perspective, we want to do whatever's best for society. Yeah. It's like, well, who determines that? Right. And that's where it gets a little bit tricky. In fact, the German law was just revised, their road traffic law, and they specifically forbid making decisions on these sorts of characteristics. So I guess the paper did get people also to be horrified and bring that actually into law.
Well, I'll move on, but for sure, if you have further questions about this, want us to come back to this, because we could spend the whole time just on this debate. I'd love to know more about how they came to their conclusions in the paper. We can do that. But I actually want to enlarge this a little bit. So let's pop out, because we've got students here as well as alumni. But how do you know when an emerging technology as dramatic as this, how do you, now that you've been through this particular situation with AV, how do you know when to start thinking about ethics?
So I'll start on this one.
Yeah.
Chris,
what have you learned from it?
I don't think there was any specific point where we said, hey, it's time to pop out the ethical handbook here in terms of dealing with these types of situations. I think it came naturally through the development process. So up to this point within the AV space, we protect for these type of issues through the use of safety drivers. So we build a safety case around the fact that we can do our testing, we can do our nominal development with an automated system under the supervision of a human, much like you would with your cruise control in your vehicle. And we're essentially delaying treatment of these edge cases until we want to remove that person. So, and I think in the process of running demos and demonstrating the efficacy of the technology, we've kind of pushed these questions down the road, and eventually we got to a point where we want to remove safety drivers, we want to have production programs, and we're forced to consider all of the potential outcomes that can happen in the real world and to have solutions for them. At this point now, we're passing essentially responsibility for the duty of care from a human to a robot.
Yeah.
And I think, as Tony pointed out, there's not necessarily one point in this. And in fact, I have the luxury of sitting here and being able to present a framework which now seems totally clear to us. But this came from a bunch of arguments back and forth in terms of like, wait, it seems reasonable that the car should be able to go over double yellow lines to avoid hitting somebody, right? That seems pretty reasonable. Don't people agree? People kind of tend to agree, right? Don't hit somebody just because somebody's striped lines on the center of the road. But then you start to be like, well, what principle did I just use? Why was that logical to me? And it was just, I don't know, hundreds of these cases that we did back and forth before it really sort of started gelling as anything principled.
That was actually the use case that we thought broke the initial assumption, right? So this started out with some of the principles, were changed, but largely were formed initially, and then we went through the process of testing this to see where we would break them, right? So we entered the conversation with, we're never going to break the traffic code. We can never find a reason where that's justifiable. And then we came up with the case of, well, what if someone jumps in front of the vehicle, there's nobody in the other lane, and it's just a double yellow line between us and saving that person. We're like, we found the case, it's broken, the legal system doesn't work with respect to AVs, and then through conversations with our colleagues within the OGC and outside of Ford for that matter, we found out there is a larger framework which does protect for these cases, and we didn't have our out. Turns out there were, the interesting thing about this was that there's specific tests associated with these legal principles that can actually be programmed in terms of requirements. So that was where we saw a lot of parallels between the legal activities and between what can be accomplished in an engineering framework, which was absolutely fascinating, at least for me.
Yeah, and this went on for weeks. We'd often spend like the periods between Wednesday and the following Monday, like not talking to each other for being on opposite sides of like one of these debates, and then we'd be like, all right, maybe.
But they're necessary. They're necessary because this is very, very serious, and actually necessary across all the things going on in this campus right now. I mean, just coming over, I'm struck with this kind of challenge and dilemma is playing out, as I mentioned earlier, in every lab I can think of, no matter what part. But here it's dramatic because we all get in cars, like I said, and we're going to go out and we're going to see these demos of cars of the future. But I must move on because I want to talk about your education. So I threw it, quickly that you were a graduate of Cal and you're a graduate of Michigan. But let's go back within that education. When you were in school, what undergrad or whatever, was ethics taught that helped you get to this point to where you can be prepared to have these kinds of discussions?
No.
Not good.
To be honest, it's like where did I get this background? Hanging out with the robot ethics community.
Wow.
Seriously, it really was learning from people and sort of having people who feel like I got it and was legitimately interested in this, and then hand-holding as I worked my way through different ethical theories and things like that. But actually, this really wasn't something that I'm bringing from my education, which is hopefully something I've tried to kind of turn around with teaching some of that.
Yeah, so tell us about that course real quick.
Yeah, so actually the course is Ethics and Equity in Transportation Systems, and I'm so excited I got an email from a student who took it with me last year asking for a recommendation letter. Is like, I just took this and went and worked in Oakland in the Department of Transportation over the summer. I was just like, yes, fantastic, looking at aspects of equity that he could get from data and things like this. So the idea is really looking at transportation as a model of understanding the fact that everything that we do, all these decisions that we make, have ethical implications. They impact on equity, and just how do we have frameworks for thinking about that, for understanding that as we go through some of these problems in general at a public policy level or at the level as we're doing of programming AVs.
Yeah, what about you?
I can't say there has been any formalized ethical training on my part, unfortunately. I heard someone mention in the crowd just before this, is it ethical applications or something along those lines, which I think would have been immensely useful coming into this. So my ethical education has been through Chris and through Emily Frascaroli at Ford.
Fascinating.
The value there of going outside of our engineering unit, for example, for advice and to bounce ideas off of, I think that's where that value came in. I don't think as an engineering team we can be expected necessarily to have all the answers, but we have to recognize when we need additional help, essentially, and we need to engage others at an earlier stage, for example, to get their input. So I would say that despite the fact that I have no formal ethical education, we knew who to leverage to get those inputs.
So talk about that. Well, how that happened. We were talking earlier, and you talked about getting out of your silo. So to address these, get this kind of skill.
So I mean, this happened organically, at least in terms of our activity. So I'd love to be able to claim that we set this up on purpose, and because of that, we did all these great things, right? We have a governance forum within Ford where we bring together engineering units, the safety elements of Ford, along with our council. We talk about difficult problems, right? If we don't have fully vetted out solutions, and we get input from the various teams before we progress too far within the design, and that has proved to be extremely effective. I think that has to do with the particular individuals and the backgrounds that they bring to this. I don't want to downplay that by any means, but I would say that is something I would take away and implement within every future activity that we do in this space. To have that governance, to be able to ask difficult questions and to get feedback from the different domains. Right. As you can imagine, our council, even with engineering training on their part, have very different viewpoints of how to solve these problems, and maybe we would approach them, or lead us in a way that get us to solutions that meet the quadrants that we've shown in the paper, for example, things that are technologically implementable, which is what we bring to the table, and things that are ethical and defensible, and that's what they're bringing to the conversation.
Fascinating. Chris, how did you do it?
Yeah, I would say, Tony described it really well. I will say one thing that was striking to me about working with Ford is, as he mentioned, there's this weekly meeting, and so, there is a weekly meeting of people who talk about these things. So it wasn't a question of, oh my gosh, who do we talk to about this? There was an initial group. And from there, we actually did all sorts of presentations to people in research, to other lawyers, to people throughout. And we kept asking them, what do you think, and can you break this? I think that was one of the aspects that was really important to us, is that we didn't really go in necessarily trying to convince everybody that we had a solution here. We said, we think we're onto something that seems like it could be implementable, it could deal with a lot of these ethical issues. What are we missing? And I think that was a question that we asked. And early on, we got some good scenarios.
I'm not going to pretend. We had scenarios that were presented to us that we had to look at each other and say, then we would talk about it, and he mentioned that we would talk on, the one day, and then we wouldn't speak again to the next week, and that was a cooling off period.
Exactly.
So you mentioned you had lawyers that were involved. Were there others, or policy people?
So we have within Ford, our automotive safety office is on the policy arm of things, as well as applications of existing standards.
And then what about outside of Stanford and Ford?
Actually, we got permission to do this, but we got permission to share it very broadly. So some early versions of this were presented in class. We presented it in a seminar in Germany and got some international feedback about it. We talked with Jason Miller, who was a postdoc in philosophy at Stanford, now a professor at University of Ottawa. He gave us some critique on this, and so we kept going and looking until we felt like, all right, we've now bounced this off of a bunch of people. Maybe we understand what we're doing.
And what's happened since it was published? Because that just happened, right, this summer. What's the feedback been, both pros and cons?
I'd say largely on the paper itself, we have had limited direct feedback. I'm sorry?
In the framework itself too. Right?
I mean, we've challenged this now through a few different mechanisms, as Chris had mentioned. I think that there are questions. We have scenarios presented to us in terms of how would you apply this framework in this given context, and we don't guarantee the ideal outcomes in certain situations. I think that there's this natural tendency to have emotional reactions in terms of what the outcome in a given situation should be. We have this example we like to show, purposely provocative, in terms of a pedestrian jumps out in front of the vehicle, and you have a conflict with that individual, or you could go into a pile of leaves in the next lane. And that usually gets people, thinking. It's like, well, I should go for the pile of leaves, for the inanimate object, right? But not considering that we can't assess the outcome in those situations, and so that may not be the appropriate reaction. And I think through dialogue, we can generally get most folks over the finish line. But I would say this has mostly been educating at this point, as opposed to being directly challenged.
Yeah.
So
one thing just to add, though, that we have spent a lot of time on is going from what's in the paper to actually getting it closer to engineering requirements.
That's right.
And that process has gone extraordinarily well.
Okay.
Not without.
I was going to say, what's next? What is
not without
success?
challenge, but and that's something that we're looking at potentially publishing as well, to kind of get a dialogue on that next level down of, okay, we think this is the right thing to do, and this is how we would actually implement it technically.
So these two are recognized as very, very important in this field. This is what makes this so special, to be sitting here and having this conversation with them. Did you ever think you're going to be in vehicles and transportation growing up? I want to just know what's been motivating you since you were a kid.
I like dinosaurs.
Yeah, so
actually,
this is not.
I did watch Speed Racer, so that was
I
early,
remember Speed Racer.
Yeah, I still think the vehicle dynamics of Speed Racer, the animated version, if you've seen like the movie version, no, the actual hand-drawn anime, the dynamics are better.
I mean, how did it come about? Now you're in this leading edge of vehicles and cars and what they're going to be
cars,
like.
and boats. That's anything that could move was of interest to me. In terms of getting into this space specifically, I would say by accident. I mean, following, there's this, one of the individuals that worked with us on this, Telus, is an author on the paper. He likes to say you have to run towards the smoke. So where the interesting problems are, and you naturally fall into these things, right?
Yeah. All right, so I'm winding down. So if you got some questions, please write them and pass them to the middle. Chris and I and Tony would love to see them. So here's your chance as we're pulling them together. All right, great. So let me finish up this third part with us. Thanks. I think they all go to Catherine first, though, right?
Yes, these are.
Oh, they're coming to me.
Yeah,
all right, thank you, Catherine. You've been at it. All right, good. All right, so let's look ahead. This is a pretty heavy issue. What are some of the other technological issues and regulatory issues regarding self-driving cars that we should be keeping our eyes on? You want Chris first?
Yeah, I'll jump into that. So, I mean, one of the big regulatory issues right now is that many people have in their mind this concept of an automated vehicle that doesn't have a steering wheel, doesn't have pedals, right? Why do you need those things if the car is going to drive itself? Could we make the space more inviting? Could we make it more accessible to people with a range of disabilities? Can we really provide transportation for everybody? The challenge is that our current laws don't allow a vehicle like that. We have to have traditional driver controls in order to pass the federal motor vehicle safety standards.
Yep.
And it's not even clear how to exempt a vehicle so that you can get it on the road if it doesn't have those things. So just recently we had 3 different examples. Zoox said, we believe we can do this without any exemptions. Ford and GM both turned in exemptions to the National Highway Traffic Safety Administration, but they asked for exemptions from different standards. Mm-hmm. So nobody seems to actually know what are the real barriers and what is the real process for getting something like that on the road. And that's actually quite different than in Germany, for instance, where they've actually been creating a legal framework to make sure that these sorts of vehicles can be homologated and get out on the road. So we're at some risk in the US of, I think, losing the advantage that we've built up over the last few years on automation. We need some regulatory clarity to be able to get these designs out there that can really make a positive impact.
I think well said. And this comes down to a key difference. So as we said, that traffic code, for example, and some of the legal frameworks around that seem to fit well with robotic drivers. The elements that Chris is mentioning are with respect to the platform itself. So federal motor vehicle safety standards and having those written specifically with a human driver in mind. And so not necessarily that there's a safety concern for doing what we want to do. We're not comfortable with the way those regulations are framed in terms of taking that next step to remove the steering wheel, to remove the pedals, and to realize a more traditional AV cockpit, as you can imagine.
Yeah.
So.
All right, are you ready for some questions from the audience? You too?
Yeah,
all
absolutely.
Right. All right.
Let's get us on their mind.
Let's do it. How do we adapt autonomous vehicles to places around the world that have different ethical norms?
That's a fantastic question. In fact, you want me to
someone
take...
overhearing us while we were talking about this?
Yeah, I was going to say, we actually were having a discussion with a visiting professor from Germany on this earlier. And I think if we sort of, break down our arguments, we think that there is a social contract of driving. But that social contract of driving is not the same in every country. Heck, it's not necessarily even the same in every state in the US, right? Because states make their own rules. And so we think the idea that automated vehicles should be programmed to obey the social contract associated with driving, that's the right concept. But then as you get into different areas, we need to think about, well, what is that social contract? And I imagine that there are social contracts in some places that are much harder to write into engineering specifications than, say, North America.
So now Chris does that very lightly, and this is where I start to squint in terms of this idea of having different duty of cares or different manifestations of the social contract. And Chris alluded to having an implementation associated with this, and this takes the form of margins and kinematic equations. And if that social contract is essentially a different calibration of that at the end of the day, then I think that's something that fits well in the framework and something that we can wrap our heads around.
Yeah.
If it means a completely different execution of this notion of duty of care of that social contract, then that's where things I think will be a little bit more difficult.
Well, so as we talked about Germany, there are some subtle differences in terms of what's expected of pedestrians. And I think that could be recalibrated, but it's an understanding that really is different in the social contract. Excuse me, as I look at videos of driving in India, we may need more than just a calibration.
Right.
Poor Chris is recovering from
Tom, if I could add one more thing
illness. Yeah.
Sorry, before we progress on that, the work that we've done up to date has largely been based on
Take your time.
North America, right? So this notion of getting out of our silos, for example, and vetting this with different groups. We've talked a lot with our colleagues in Germany. I mean, that is the next phase of that work. Understanding, is this more broadly applicable? What needs to change? And so, I mean, we're giving this talk today. This is incomplete work in the sense of we in terms of broad applicability, we still have to understand what that means.
Yeah. All right, so that was question number one. Question number two has three parts to it. So we'll just take it in totality and instead of all three. How about that? How do you ensure the ethical behavior of the safety driver or the person programming the machine? A little deeper maybe here. What are your thoughts on the legal differences by country and traffic laws? I think we just did that. German values versus US. We just did that, as a matter of fact. And if your team is misaligned on values, ethics, how do you resolve the friction? Who decides?
I have thoughts on the first and last one of those.
Yeah, let's do those.
One.
Yeah, let's do the last one.
If people disagree with me, then I
if your team is misaligned on values and ethics, how do you resolve the friction? I actually like that one. Who decides?
Well, I mean, this is a broad team working on this at the end of the day. We didn't get a chance to formally acknowledge them, but there's a lot of contributors to this activity. And this really was data-driven. So for as much as we didn't want to take a bottom-up approach in terms of deciding outcome scenario by scenario, we were looking for principles that worked broadly. And I would say that there were numerous times where people bring in scenarios and it challenges our thought process. Maybe we have to make tweaks, but it largely, if we're going to deviate from an existing framework that we've tested, there needs to be evidence to support that. So at the end of the day, I mean, if there needs to be a tiebreaker, then I win.
Yeah. Oh, you doing okay, bud?
Yeah.
All right, so I got a good one here because 2 weeks ago or something like that, Stanford started a new school, the Stanford Door School of Sustainability. So this is right down that alley. It's the first school in 80 years. It's on par with business school, engineering school, humanities school. It was an incredibly exciting week and concept. So let's get after this one. I feel as though we have missed a crucial step when evaluating the ethics of AVs, which is evaluating the ethics, which is should they exist at all? Here we go. Yeah, AVs at all. That's it. That's the good punch. Studies estimate up to looks like 45% here. I'm having a little trouble reading this. Increase in CHG or carbon due to increased driving, empty vehicle miles, and further commutes. How do we reconcile with AV tech adding to the climate catastrophe?
Yeah, it's a good question. In fact,
Sure
actually,
is.
when I taught my course on ethics and equity in transportation systems, I encourage the students to be critical all quarter, and then we talk about automated vehicles, and this is one of the questions that come
Sure.
up. They're like, is it even ethical to work on this? I think these are important aspects to think about in terms of, where do we need mobility and who needs mobility. I think if you look at people who are disabled, who have less access, who due to aging are losing the ability to drive, you have a large population of people who are lacking mobility options. And I don't see a lot of other alternatives at which society can provide those sorts of mobility options at a reasonable cost. Now, is it a reasonable cost today? No. Can it be provided today? No. But I think it really is an option which can enable this. Now, does making mobility inexpensive and ubiquitous have problems? Yes, absolutely. And so I think, as we've been coming through the pandemic and realizing that there are some advantages for getting together in person, there's a lot that can be done remotely. I think these are things that we have to pull into that mix. But I really do think that it is an important thing to be able to enable mobility. And I don't see a lot of options there. If you talk to people who are experiencing, say, paratransit as part of public transportation today,
Right.
it just does not work.
Yeah. Want to add anything to that? Or
Just the development of technology, especially new technologies like this, I think we're confounding to some degree the development of robotic drivers and potential impact on the environment. I think at this point in the development, we're still a little bit early in terms of understanding what those links look like. There are benefits that we can enable through AVs in terms of staging vehicles, in terms of taking them offline when not in use that you can't realize with human drivers. And that's not to suggest that there isn't a problem here. There's nothing worth studying. I think this is a separate topic that does require in-depth thought, much like we've done on the ethical side for the driving policy itself.
yeah, and this would be a good place to do it with our new school. I hope they do with you. Here's another one that's interesting. Similar to the crossbody seatbelt from Volvo, how can car companies work together to keep the general population safe? I guess it's talking about collaborations and partnerships.
Yeah, I'll address this because this is probably not as widely known. But a couple years ago, we were a founding member of the Autonomous Vehicle Safety Consortium.
Yeah.
So for those that are familiar with SAEJ standards or ISO best practices in those spaces, this group formed together as developers. So these are not industry experts. They are companies that banded together to address safety issues around AVs. So it started off with understanding platform considerations, things like passenger-initiated emergency stops, for example. There was a question about safety drivers. How do we train them? What responsibilities do we hold against them? And this has evolved into safety assurance of the ADS itself. So there is a group that is out there. It's I believe about 7 companies right now. You can look this up in the off time and quiz me on this, but
Yeah.
there are industry groups that are coming together with the motivation of improving safety for the public. And in fact, that's one of the only reasons we can have dialogue in this space in a non-competitive sense is around safety.
And these are published best practices.
Correct,
So
and these
that
are freely
the public can
available.
go out there and say, look, these are the things that are being taken into account in safety assurance, or these are the sorts of standards that are being used for test drivers. And some state governments have actually been taking that as a basis for saying, okay, this is the way industry is going. We want to actually put some requirements and some regulatory teeth around some of these things.
In fact, one last comment on this, when we write those documents, and this is addressed purely in the purpose, they are for other developers that are getting into the space, they are for authorities that may be looking for guidance on the topic, but they are also for the general public to understand how we're thinking about these problems as it relates to things like driving policy, for example. What are my expectations for AVs as a VRU, for example? That was one of the more recent publications that we put out there.
I like this next question because we have all generations in the room. I'm telling folks that are watching online, it's really fascinating. This is just perfect. So this is the reason. There's somebody asking a question that clearly is a student, and that warms my heart. I'm sure yours too, Chris. What problem do you hope the next generation spends the most time thinking about? I'll narrow it down to this sort of space. There's a lot of grand challenges going on in the world right now. But what problem do you hope the next generation spends the most time thinking about?
How to talk to each other? I mean that very seriously. I feel like we've lost something there, and if we could actually do that, then I think these other problems start to become solvable.
That was pretty good, wasn't it? Yeah, that's pretty good. Let's give it a round of applause. As a matter of fact, I have a suggestion. Why don't we continue? There's lots more great questions here, but why don't we continue that over, I don't know, food and beverages to the audience online. We certainly appreciate you joining us. Wish you were here to go out and see the cars that were featured in that video. But for those here, if we didn't get to your questions, we're going to be hanging around. So Chris and Tony would be glad to talk to you about them. It's been a real joy to be the moderator here. These two are the leading, or part of a group of the leading experts in the field, and I certainly learned a lot. Did you? Did you? Give them a round of applause.
Tom, thanks for doing this. I want to also add that in addition to the cars out there, some of the students featured in the video will be found outside talking about their work in the cars.
Oh yeah, and that one in particular, the mom who's talked about safety, and it's brought it home to us saying, you better believe I think about safety. That was really powerful. So is she here, I hope?
I think she may be with her daughter.
Yeah, so. There you go. Well, okay, there you go. But a really powerful message. All right, so as they say, should we declare victory and bring this to a close? Thanks so much, everybody, for being part of this.
Thank you, man.